Okay, this is an answer video to section 7.1 in your MathLinks 9 textbook on multiplication of a monomial by a monomial. Now, the first question that we did was question 3. I think we did 1 and 2, but the first question I'm going to answer is question 3. It says, what multiplication statement is represented by each set of algebra tiles? Now, what this model is basically, if you think about a rectangle has a length and a width, and the area is the amount of square units inside a rectangle, right? Or the product of the length and the width would be the area. So that basic idea of an area model applies to this model because we have a length here and we have a width here. But instead of using numbers that we have used since elementary school, what we're using here is algebraic tiles. So this tile is an X, this is an X, and this is an X. And the reason why it's an X tile is because this tile has a length of X and a width of 1. So the area of that tile is X. But the length that we're concerned with is an X, an X, and an X. So really that length of the rectangle is going to be 3X. Multiplied by the width of that rectangle, multiplied by 2X. So the expression that is being represented here is the multiplication of 3X's by 2X's. And when I look at the area, or the amount inside here, what we end up having is 6x squared as our solution, or our area. So length times width equals area, or 3x multiplied by 2x equals 6x squared. In B, the length of our area is going to be, again, 3x. But this time, our multiplication is not going to be a positive x. It's going to be a negative 2x as a length. And when we multiply those two together, we're going to equal a negative 6x squared. And we differentiate between a positive x squared and a negative x squared, or a positive x and a negative x. Positive x's are shaded in green, or just shaded in, and negatives are always going to be empty or white. And finally, in our third one, our length is negative 3x multiplied by the width, which is negative 2x. And our area inside there is going to be a positive 6x squared. Okay, and we know that because of our integer rules we learned in grade 7, that a negative times a negative is a positive. Question 4. Question 4 is an extension, so we have, again, 3x by 3x, or 3x multiplied by 3x as the length and width, and the area inside is 9x squared. Here we have a length of negative 2x and a width of negative 2x. And the product of those two when multiplied is going to be a 4x squared. And finally, our last one, we get these orange tiles and these crazy gray ones. This is going to be right here. These are y tiles. And the length is y and the width is 1. So it's going to be a 2y multiplied by a 1x. And our answer is these little gray ones, which we're going to call xy. Now, some people might write down 2yx, but when you have variables in your expression, more than one variable, and you're simplifying it in terms of the product or the sum or difference or whatever, you should replace them alphabetically, so in alphabetical order. So our solution is going to be 2 xy tiles, and those are the gray tiles, so they're called xy. They have a width of y and a length of x, if you want to call it that, and therefore, since we can't multiply an x and a y together because we don't know what the numbers are, we just express it as x times y, or xy. Question 5, I'm only going to do a couple of these. I'm not going to do them all. It says model and complete each multiplication statement. I'm just going to do B and D for all of the modeling, save us a little bit of time. So here, my length is going to be negative 4x. I'm just going to draw x's, and these are really poorly done, but anyway, 4 negative x's, not positive. And my width is going to be a positive 2x, so shade it in. And once we have that, you can connect the dots, make your area. Just draw the line straight down from there and draw your line straight across. Ask yourself, are those going to be positive x squareds or negative x squareds? And because it's a negative multiplied by a positive, we're going to have negative x squareds inside. So if each one of these is going to have a length of negative x and a width of positive x, each of them is going to be negative x squared, which means the area, or the product, is going to be negative 8x squared. In our D, we're going to do the same thing, except this time actually it's going to be the exact same question, isn't it? If we think about it. D, the only difference between Can I do this, I wonder? Let's see if I can delete that. The only difference is these are going to be negative instead of positive, and these are going to be positive. But the interesting part about that is when we switch them, the area is still going to be the same. It's still going to have a negative 8x squared as its area, just reversing the length and width. Question 6 says represent each multiplication statement with a model. So again, we're going to do B and D. So we didn't do 6. Okay, we'll skip it around then. Question 7 says find the product of each pair of monomials. So for question 7, you didn't have to model it. And the second method we learned for how to find the product of a monomial times a monomial, if we think of 2y multiplied by 5y, it's really the multiplication of a 2 times a y times a 5 times a y, right? And when we think about that, because of the commutative property of mathematics, the order in which you multiply a string of numbers together does not affect its product. So I could reverse this in any way I want, and if I reverse it to this way, this should still be the same product. And in doing so, I could then say, well, hold on, 2 times 5, well, that's 10, and y times y is y squared, because I learned that during my exponent chapter. So therefore, I know the solution to this is going to be 10y squared. Another way to think of it is simply, if I grab my highlighter here, multiply your coefficients together, you get the product of the coefficients, and then multiply your variables together and express it in exponential form, and then you have the product of both a coefficient and variables. Let's do B again. So if I follow that same thing, if I multiply my coefficients, a 3 times a negative 6 is going to be a negative 18. And then a times b, since I don't know either variable, I can't express that with exponent rules because they're not the same base. So as a result, I can only express it as the product of a and b, and the product of a and b is simply going to be ab because that's a times b. So really, the same thing would be negative 18 multiplied by a multiplied by b, or negative 18ab. Over here, for C, sometimes people look at a negative q and don't think of it having a coefficient, but we learned before that the coefficient for negative q is actually a negative 1q. So if I follow that same rule, this would be a negative 1 multiplied by q multiplied by negative 9 multiplied by q. And I know the 9s and the q look alike, that's why I put the little doohickey at the end of the q to make it sure it's a q, not a 9. Multiply the coefficients together, or the negative 1 and the negative 9, and you're going to get a positive 9. And multiply the q times q, you get q squared. D gets a little more complicated, but if you use the same rule, so it's going to be 2/3 multiplied by x multiplied by 3 multiplied by x. If you multiply your coefficients together, or 2/3 multiplied by 3, this is a grade 8 outcome when you learned how to multiply a fraction by a whole number. That's going to become 6/3, or just 2, right? So when you multiply the coefficients together, you're going to get 2. And when you multiply the variables together, x times x is going to be x squared. Question E, negative 3 times negative 2 is negative, or positive 6, excuse me. R times T, element of P, Q, R, S, T is going to be RT, alphabetical order. So 6RT, that looks like art. And finally, the last one, 1.5 is a coefficient and negative 3 is a coefficient. If you think about just 1.5 times 3, that's 4.5. So it's going to be negative 4.5 P squared. Question 8, do we have to do that? Okay. So real quick, 6n squared, 28k squared, negative 10w squared. Here we're going to do 3/5 multiplied by 15, or 15 over 1. I forgot to tell you, you should cross reduce if you can, because you're multiplying two fractions together. So 15 over 5 will reduce down to 3 over 1, which gives us 9 over 1, or just 9. So multiplying 3/5 by 15 gets you a negative 9, because it's a negative 3/5. X times x is x squared, so negative 9x squared. Here, I'm multiplying an 8 by a half, and if I reverse that and think of it as being half multiplied by 8, or half of 8, because of is multiplication, I could do it in my head that 8 times a half, or a half of 8, is 4, right? Which will be a negative 4 because it's a positive coefficient times a negative coefficient. M times n, I can't express it more than just m times n, or mn. And finally, your last one, this is a 1t times a negative 7t. So multiply 1 by negative 7, you get a negative 7. T times t is t squared. Question 9 is kind of a story problem. It says a rectangle has a width of 3.9x and a length of 5x. What's an expression for the area of the rectangle? In this particular question, if this was a test question, I would fully expect that you actually drew the rectangle. And then you also did this. You said area is equal to length times width, or area is equal to 5x multiplied by 3.9x. If you multiply those coefficients together, 5 times is 19.5, and x times x will be x squared. So therefore, the area would be 19.5x square units. Question 10 gets a little bit trickier because it's a parallelogram, and the last time you saw a parallelogram was grade 7. But the area of a parallelogram is simply base times height. And you remember back in the day when you learned about it, that's how we learned how to get the area of a triangle, because base times height divided by 2 was really just the half of the parallelogram, right? That's where the area formula for a triangle came from. But area of a parallelogram is simply base times height, or in this case, the base is 8.1z multiplied by 4.2z. Multiply your coefficients. Now this time I can't do it in my head. 8.1 multiplied by the other coefficient gives us a refined coefficient of 34.02. Is that right? And then z times z will be z squared. So therefore, your area of the parallelogram would be 34.02 z square units squared, which, because we don't know if these are meters, these could be meters or centimeters. And as a result, since we don't know, we would say that it's 34.02 z squared units, or square units of area. Question 11 says write the division statement. Now we talked about before, if you had an area of 10 square meters, and I told you the length of this was 5 meters, it wouldn't take many people too difficult if I said, what's the width? A lot of you would know it's 2 meters. And if I said, how did you know that? You would say, well, 5 times 2 is 10. But what you really didn't know is that you took the area and you divided it by a side length to get the other side. So side 1 and side 2. Right? You took the area, or 10. 10 divided by 5 told you this was 2. So that idea is what we use for these area models, meaning the area divided by the side we know will tell us the side we don't, or 6x squared, which is the area, divided by 3x will tell us the missing side. And if I fill in what would they be there, I could just say, well, okay, this is going to be this shape. Are those going to be positive or negative? They're going to be positive because a positive times a positive. So therefore, based on the area, I know that the missing side length has to be 2x. In the next one, if I wrote down the area here is 8xy divided by the side length that we know, which is 2y, will mean that this here is going to be positive or negative. They're going to be positive. It's going to equal 4x's. Right? And finally, C, area is negative 6xy, right? Because they're not shaded in, they're empty xy's. I think those are xy's. Are those x's? Those are x's, aren't they? It's kind of hard to tell here. Negative 6x squared. My board's a little oblong. Divided by the side we know, which is 2x, will equal, these have to be positive, because, or no, these have to be negative, don't they? Equals negative 3x. Do yours look squarer than mine? Yeah, mine looks kind of look like rectangles. That's just a distortion, I think, of the smartboard. Question 12, do we have to do? Yep. So our area is 9x squared divided by the side we know, which is negative 3x. The missing side length, are those going to be negatives or positives? Negative, because a negative times a negative is a positive. So our answer is negative 3x. And finally, the last one, our area is negative 9x squared divided by the side length we know, which is negative 6x squared, not 9x squared. Oops. Negative 6x squared divided by negative 2x means the missing side length. These have to be positive because a positive times a negative is a negative, equals positive 3x. Question 13, we'll just do a couple of them. Let's just do A and B. Let's just do A and B. So modeling complete each division. So if the top number represents the area and the bottom represents one of the side lengths, we're actually going to start by drawing the side length first. So I'm going to put a 2x here. Okay, I'm going to start with 2x. And then I'm going to figure out if I want to put 8x squared in there, I can kind of figure out I need to have 4. Oh, this is really poor. Oh, that's the worst ever. Hang on. Let's cut this up a bit. Let's cut it up into here. And then a little bit over here. There we go. So that allows me to fit positive 8x squared in the middle. That's the only way I could fit it in based on the fact that I had my side drawn first. And these up top here, are they going to be negative or positive? They're going to be positive because a positive times a positive gave me the positive area. So therefore, the answer is going to be 4x's. So 8x squared divided by 2x, 8x squared divided by 2x is 4x. And B, hang on, equals 4x. B, 5xy, this is where it's going to get tricky. So our area, 5y, I'll put 5y here. Oh, that's not a y. That's kind of a y there. Y, 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 y. And 5xy, well, that's going to be easy. Positive y, positive y, positive y, positive y, positive y. This is a positive xy, positive xy, positive xy, positive xy, and positive xy, 5xy. Therefore, this side length has to be, I should probably shade these in, shouldn't I? These are positive in here. Therefore, my side length has to be a positive x, right? So my answer is going to be simply x. The width is x. Or 5y times x is going to be 5xy. I will. Question 14, do we have to do that? Skip it. Question 15. Okay, question 15 asks us to find the quotient or the answer to the division without modeling. And what we're going to do for this, if I take 7x squared divided by x, and I think of it as the product of separate parts. I can think of it as the division of the coefficients multiplied by the division of those variables multiplied by x over 1. Now, if I think of it this way, and I had 3 fractions, the first fraction being 7 over 1, the second fraction being x over x, and the third fraction being x over 1, and I asked you to multiply them together, by grade 8 standards, you would multiply the numerators to get 7x squared, and you would multiply the denominators together to get x, which is actually what our starting question was. So what we're going to do is we're going to think of our question, I'll use yellow here, as separate parts. And we're going to simplify each of those parts to simplify the division itself. 7 over 1 will simply be 7. X over x will simply be 1. And x over 1 will simply be x. So each of those independent fractions will result in those 3 parts. So therefore, 7 times 1 times x is just going to be 7x, right? So the answer to that division will be 7x. For the second one, B, 25 st, so 25 over 5, the coefficients first, multiplied by one of the s's over one of the s's, done, multiplied by the t that does not have a t on the bottom, so we're just going to replace it with a 1. Simplify each of these parts. 25 over 5 will reduce down to 5 over 1, multiplied by s over s, which is going to be 1 over 1, and t over 1 will stay as t over 1. When you multiply the numerators, you get 5t. Multiply the denominators, you get 1. Sorry, this is equal. And therefore, the solution is going to be 5t over 1, or just 5t. Now, without having to rewrite all of this mumbo jumbo, you can do it without having to rewrite it all. Because you can just look at it and say, okay, I'm going to divide those coefficients together. So 125 divided by 5 is 25. T will be by itself because it can't cancel out with anything. So our solution to this is going to be simply 25t. Negative 8 over negative 2, that will reduce to 4 over 1, which is just 4. M over m will reduce to 1 over 1, which is gone. So therefore, the solution to this is just going to be the number 4, right? Negative 8m divided by negative 2m is 4. Look at the next one. I'm going to break it down into its parts again. If I think about 81 times r times s, I'd get 81rs. If I think about 3 times r times s, I'd get 3rs. Break down each of these parts into its lowest terms. How many 3's are in 81? There's 27. R times r will just become 1. S divided by itself will become 1. 27 times 1 times 1 is just 27. And your last one, put the coefficients over each other, multiplied by p over one of the p's down here, multiplied by one more p over, we'll just put a 1 there to occupy space, 4.5 over negative 3. Now, there was a very smart student that struggled with this one. But what I want you to do is when you have this, I want you to reduce your coefficient or your denominator of your division or your quotient of coefficients down to 1 as the bottom number. So how would I do that? I would divide it by negative 3. So I'm going to divide the top part by negative 3, and that should reduce it down to 1. So as long as my denominator is a positive 1, I've eliminated the coefficients, right? So 4.5 divided by negative 3 is going to be a negative 1.5 over 1, multiplied by p over p is going to become 1, multiplied by p over negative, or 1 is just going to become a p. Multiply that string together, I get my final answer of negative 1.5 singular p. Question 16. Do we have to do this one? Yeah. Don't forget that this question is probably a heck of a lot easier if we write it out like this, right? Since they're the same thing. Coefficients divided by coefficient that doesn't exist will just be 12.4. An x squared divided by an x will just be an x. So you get it like that. Rethink this one as being negative 15r divided by negative 4r. Think of it as the parts of each part, r over r. Here, I'm going to divide top and bottom by what number to get r? Negative 4. So divide top and bottom by negative 4. That is going to leave me with 7.5, 3.75. Positive 3.75 over 1 multiplied by 1 over 1, or simply 3.7, positive 3.75. 3.75. Of the remaining ones, let's just try these two. I'm going to do these two. So here we're going to break it into k over 4k, okay? And when I break it into the coefficients, it's going to be 1, which is the coefficient that's not written over here, over the bottom coefficient, which is, oh, hello, over the bottom coefficient, which is 4, multiplied by k over k. Now here we have an interesting one because 1 divided by 4, if I divide both by that 4 coefficient, I'm going to get what coefficient as a result? What's 1 divided by 4? 0.25. So my coefficient, you can think of it as either 0.25, or if you wanted to, you could think of it as a quarter. And k over k is going to become 1. So therefore, my solution This is going to become 1 over 1. My solution is simply 0.25 or a quarter. And our last one, 2/3 x squared divided by 2x. If I rethink my parts here, so 2/3 divided by 2 multiplied by x over x multiplied by x over 1. 2/3 divided by 2, or 2/3 divided by 2, is the same thing as 2/3 multiplied by the reciprocal of 2. And what's the reciprocal of 2? What's the reciprocal of 2? 1 over 2. Oh, heavens. Sorry. So these are the same question. Cross reduce. 2/3 divided by 2 is just a third. That makes sense. If you had 2/3 of a pizza divided between 2 people, each person would get a third of it, right? So 2/3 divided by 2 is going to end up being a third. X divided by x is going to become 1. And x over 1 is going to become x. So therefore, 1/3 times 1 times x is just going to be 1/3 x. Now please note, another way to write this, a third of x, is this way, right? That is still a third of x, or x divided by 3. A third of x, or x divided by 3, the same expression. This would have been the one you would have used in grade 7 and 8, and then in grade 9, once we start chapter 8, which is our next chapter on algebra, we will use fractional coefficients like that instead of division. Okay, question 17 says find an expression for the area of each figure. So just like the other ones, area equals length times width. Area equals 11x multiplied by 3x. The area equals 33x squared. Here, base times height divided by 2. If you want to write it like base times height in brackets divided by 2, that's fair as well. Or 10p multiplied by 4p divided by 2, which is 40p squared divided by 2, which means the area of that triangle is 20p squared. Half of 40p squared would be 20p squared. And your last one, this is an interesting one because we haven't done squares before. This is a square. And the formula for a square is side squared. So technically, 1/2 w in brackets squared is the same thing as 1/2 w multiplied by itself, which is 1/2 w. That's what squaring means. Multiply the coefficients. What's a half times a half? No, that's a half plus a half. Half of a half is a quarter. And what's w times w? W squared. So our answer is the area equals 1/4 w squared, or alternatively, a quarter of w squared could be written as w squared divided by 4. A quarter of w squared. Yeah, so half of a half. Yeah, I'll show you later. Question 18. Here we have a division statement. So the area divided by the length that we know will equal the missing. So 15 divided by 5 is going to be 3 when I divide my coefficients. X squared divided by x is simply x. So the missing side is 3x. Or 5x times 3x gives us the area of 15x squared. And our last one, area equals base times height divided by 2. Area equals, 3.3 w squared. 3.3 w squared equals the base, which I don't know, multiplied by 1.1 w divided by 2. So now we have an algebra question. And this is a really tricky question. So pay attention. What's the first thing I'm going to do to isolate for b? And there's no constant. I want to get rid of this part right here. So instead of having half of that, I'm going to do what to both sides? No, I'm going to multiply both sides by 2. If I multiply this side by 2, instead of having half of it, I will have all of it. Does this make sense so far? I took my formula. My base, I didn't know, so I left it as b. My height, My h I knew to be 1.1 w divided by 2, and I knew my area. So my area was substituted in for 3.3 w squared, and everything else was substituted in. Now, remember, my goal is to isolate for b, because I want to know what b is. So what am I going to do to both sides now? I want to divide both sides because I want to isolate for b by what number? No, 1.1 w. And by doing that, I end up with an isolated b equals 6.6 divided by 1.1 is 6. W squared divided by w is w. And therefore, the base must have been 6w.